What if we could just ask an AI to watch over our planet? I mean, really ask it to monitor deforestation, track how our cities are growing, or even predict how well crops will do, just by looking at pictures from space. It sounds like something straight out of sci-fi, right? Well, a new solution called TESA, which was developed for the Smart India Hackathon, is making it a reality. So, let's dive in. This isn't just some hypothetical question. It's the huge challenge right at the heart of modern Earth observation. We've got petabytes of data, just a fire hose of information, streaming down from satellites every single day. The real question is, how do we make sense of it all? Not just quickly, but at a massive scale. To really appreciate what TESA pulls off, we first have to wrap our heads around a massive blind spot in some of our most powerful AIs. They are absolutely brilliant, but in a really important way, they can't see a thing. It's a fascinating paradox, really. We have these incredible open-source language models, like GPT-OSS, that are total wizards with words. They can write reports, analyze text, answer super complex questions. But if you show them a satellite image of a coastline or a multispectral scan of a forest, they get nothing. They are completely blind to the visual data we need the most to understand what's happening to our planet. And this is the exact challenge that the Indian Space Research Organization, ISRO, put on the table. They needed a way to give these powerful text-based AIs the gift of sight. But, and this is a big but, the rules were strict. It had to be fast and avoid the old, clunky methods that are slow and tend to make things up. It absolutely had to be trustworthy, with every single answer backed by real visual evidence. And it had to be efficient enough to work on hardware that people actually have. And this is where TESA enters the picture. Think of it as this elegant, incredibly smart vision bridge. It's the thing that finally connects the powerful language part of the AI's brain to a brand new set of eyes looking down on Earth from orbit. The name TESA actually tells you everything you need to know. It stands for Token Efficient, Evidence Grounded, and Sensor Aware. What that really means is that it's a specialized translator. It takes these rich, complex satellite images and converts them into a language that the AI can finally understand. And this doesn't just let the AI see a picture. It lets it reason about it and explain what's actually happening in that image. And that's the trifecta that makes this such a game changer. See, reason, and explain. It's one thing to see an image. It's another thing entirely to reason about what that image means, especially how things are changing over time, and then to actually point to the visual evidence for its conclusions. This is a huge shift in how AI can interact with the real world. Okay, so how does this smart bridge actually work its magic? Because the technical design here, this is where the real genius of TESA is. The approach is just brilliantly efficient. Instead of trying to build a new massive AI from scratch, the team behind TESA did something much cleverer. They took a powerful existing language model and a powerful vision model, and they left them frozen, totally untouched. The only thing they trained was the tiny bridge that connects the two. That means they get all the power of these giant models, but without the insane computational cost of retraining them. So here's how that little bridge works. It doesn't just send a raw picture over. No, instead, it builds a really descriptive image sentence for the AI to read. This sentence is made up of special tokens. You've got spectral tokens that describe light we can't even see, semantic tokens that identify things like rivers and buildings, and geotemporal tokens that pin down the exact when and where. And maybe most important of all, delta tokens, which highlight exactly what's changed from one image to the next. And this is the truly mind-blowing part. All of that rich, complex information from a massive satellite image gets compressed into just 24 tokens, sometimes less. Now, to put that in perspective, older methods would need hundreds, maybe even thousands of tokens to do the same job. That made them slow and incredibly expensive. TESA is just a masterclass in doing more with less. So we know TESA is incredibly efficient, but let's be honest, raw speed doesn't mean much if you can't trust the answers you're getting. And this is where TESA really truly shines. Its relentless focus on reliability and trust. And this really gets to the Achilles heel of so many modern AIs, the problem of hallucinations. When an AI just makes stuff up. If you're using AI for scientific analysis or for making policy, an answer that's just made up isn't just unhelpful, it's downright dangerous. So how does TESA solve this? TESA's answer is a special component called the verifier. You can think of it as a built-in fact checker. It is constantly double-checking the AI's conclusions against the raw pixels, the visual evidence. And if the data doesn't back up an answer, the system doesn't just guess. It has the humility to say, I'm not sure, or my confidence here is low. For scientific work, that feature is absolutely critical. And the numbers prove it. While other models might be able to back up their claims with evidence around 65% of the time, TESA hits a remarkable 92% citation rate. That's not a small step up. That's a monumental leap in reliability. And what's more, it achieves this incredible reliability while being more efficient. TESA uses almost 30% less memory. This isn't just some small technical tweak. This is a huge step toward making this kind of high-level AI analysis more accessible and affordable for everyone. And the wins just keep stacking up across the board. TESA is more accurate at identifying what's on the ground, it's better at detecting changes over time, and it's just plain faster than the other options out there. All right, the technical stuff is super impressive, but let's bring this back down to earth. What does all this actually mean in the real world? How does TESA turn all this data into actual, useful insights for people making important decisions? Well, it means a policy analyst can now just type a simple question like this one, in plain English. No special software, no waiting for a whole team of data scientists to go find and process all that data by hand. It means a city planner can ask to analyze decades of imagery to see how a city has grown and get back a clear summary where every single point is tied directly back to the visual proof. And it means an agricultural agency can keep an eye on crop health across an entire state, almost in real time. This is the true power that TESA unlocks. conversational, evidence-based insights delivered at the speed of a question. So, who does this empower? Honestly, the list is huge. Of course, space agencies like ISRO, who can now unlock the true potential of their massive data archives, but also policymakers who need solid evidence, researchers who can speed up their work, and even individual farmers who can get insights to improve what they grow. This absolutely incredible solution, TESA, was the work of Team Eagle Eye for the Smart India Hackathon. It's just a powerful reminder of how focused, clever innovation can help us tackle some of our planet's biggest challenges. Thanks so much for joining.